In this video, we'll explore some of the essential characteristics of data warehouse and compare a data warehouse with operational databases. Now, data is one of the most essential components that any organization would like to measure. The amount of data created today in global IT environment is immense, and they provide opportunity to the enterprises to evaluate the data and perform analytics, so they can tune their business applications and their business activities. A data warehouse is one of the relational databases that was essentially designed for querying and analysis on a huge amount of data in order to produce useful information. And there are various types of data that we can manage using data warehouses. Using a data warehouse, we can store historical data that are derived from the transactional system and provide the capability of enhancing analytics on the historical data. With data warehouse, we can load a wide range of data from a variety of sources. Such sources can include big data environments, relational databases, and even ERPs. Now, data warehouses also provide the capability of separating the analysis workload from the transactional workload. We can provision various systems that can handle or manage all the transactions, and data warehouse in turn can take the responsibility of providing a separate layer of analytics. There are various tasks that can be included as part of data warehouse implementation. Most of the data warehouses today provide the capability of extracting information, transporting the information, and transforming the information so they can adapt to the environment where they're being implemented. Data warehouses also provide the capability of extracting, loading, and transforming data as a part of its essential solutions. Finally, data warehouses also provide online analytical processing capabilities, and most of the data warehouses today provide inbuilt data mining capabilities as well. Now let's explore some of the essential characteristics of a data warehouse. A data warehouse is subject-oriented. We can use data warehouses to analyze a particular subject area. For example, we can consider sales as a particular subject area. We can consider inventory as a different subject area. And we can consider human resource as a different subject area. So we can analyze information on the basis of the defined or identified subject. Data warehouses are also integrated in nature. In simple terms, the variety of data that we get from multiple data sources can be integrated, and a particular schema can be derived in order to provide fruitful analysis on the data. With data warehouses, we get or they provide non-volatile data. So when we store data in a data warehouse, they never change, and as such, we can continue tracking data that we've stored in a data warehouse. Finally, with data warehouses, we can facilitate time-variant data. We can perform analysis on the data depending on the historical nature of the data that we've imported or loaded in the data warehouse. We can perform analysis using weekly, monthly, yearly segregation of the data, or even depending on the timeline of a particular data, and it's useful during a particular historical time. We can facilitate time variance to the data to address various analytical requirements that are dependent on time. Now, let's compare certain aspects of OLTP and data warehouse. The comparison will be based on various elements that are useful when executing queries on the data. In terms of data structure, we get a complex data structure with OLTP, unlike multidimensional structures that we get in a data warehouse. Now, in a typical OLTP implementation, we'll find fewer indexes as compared to a data warehouse, since data warehouses are implemented for search and analysis. We'll find multiple joints in OLTP as compared to the data warehouses, where we find fewer joints. And this is mainly because we have a higher level of normalization in OLTP, whereas in the case of data warehouses, the data are generally denormalized. Another comparing element is the existence of duplicate data. With OLTP, there will be no duplicate data, as it is designed to avoid duplicate data with high levels of normalization. This is not the case with data warehouses. Since the database is denormalized, we'll find duplicate data. The final comparing element is the derived data and aggregates. With OLTP, the derived data and aggregates are quite rare, where in the case of data warehouse, derived data and aggregates are quite common. To facilitate analytics in data warehouse, we'll be using lots of aggregation, and we'll also need to derive value from the existing data. And these are some of the differences that we'll find in an OLTP implementation and data warehouses.